Yep, after a year of development on my dream game in Unity, I decided to throw it all out and start again from zero. The short version is that I got really frustrated with all the technical debt in that project, but also with Unity itself. It was a tough decision, don't get me wrong, there were plenty things that I really liked about that project and that I didn't really strive to remake. But I was at the brink of rewriting half of it either way, so why not start completely fresh in a totally different engine right away? After all, I bet I can do much better in Unreal Engine anyways. Which brings us here, a fresh new project. Why even pick Unreal Engine, you ask? It's really impressive, it can render
billions of triangles
without any issues. Although for my low poly project, most of that is probably not that relevant. But either way, I'm also a big fan of the low poly coding using C++, and in combination with their Blueprint visual node-based coding system, which is ideal for smaller top-level implementations, it really drove the point home for me. Do I even need those low-level coding capabilities though? To be honest, C# would probably suffice. However, C++ really allows me to get the best out of my visions, especially with the possibility to tweak the source code of the engine to my exact needs, which finally brings me to my plans for this game. If you've watched my first video, you might have noticed that I never really talked about what kind of game I even plan on making, and there actually is a really good reason for that. I didn't know. This project started out of the rough idea to make a game with infinite procedural generation, but it was only at a much later point where I thoroughly thought about what kind of game I even wanted to make. Even that changed over time though, as I realized that my plans were just way too ambitious and have fallen victim to scope creep repeatedly. It's just always so tempting to add this and that additional feature. After all, how complicated could it be? But then, all of a sudden, you're looking at the scope of a AAA game. To cope with this, I decided to not only make a single game, but two. I know, I really mastered setting limits for myself. But hear me out. My dream game idea, which I'll get to in a moment, will in no way stay within a manageable scope for me. So instead of either starting a project that I'll never finish because it's way too big, or starting a project that I'll never finish because I'm not really passionate about it, I'm going to start with a smaller project that shares a lot of the back-end features and properties with the big project I'll eventually grow out of that. This allows me to have a motivating in-between milestone that will additionally help me to thoroughly test the framework that I'll also be using for the much more ambitious game. Will I actually play the system or just myself with that strategy? Well, we'll have to see. That finally brings me to the concept for that big dream game though. First and foremost, an infinite sandbox voxel world of course. This is going to be a hybrid of smooth low poly terrain and also blocks for structures and building. In terms of gameplay, I plan on a similar resource and technology progression to some of the old Minecraft mod packs. You probably have played some of those as well. They just get me hooked every time. I do want to lean more towards sandboxy automation though, so some features are definitely going to be Factorio and Satisfactory inspired. Also, one more thing that I really want to achieve is to enable and even encourage a playstyle similar to technical Minecraft. I don't yet exactly know how to achieve this, but the plan would be that by building a solid foundation and focusing on simple features that can interact with one another, but most importantly embracing an iterative development cycle with hopefully loads of player feedback, we can build this together. Now it's about time to finally get back to that fresh Unreal Engine project though. The parts that are going to be shared with the smaller game mainly include the voxel world, framework and a bunch of UI and player stuff. So let's start with the world. How do I actually start though? Turns out, Unreal Engine is, after all, quite different to Unity. I had an especially rough start since I really wanted to implement a lot directly through C++ code, but getting that set up happened to be everything but straightforward. When I finally stumbled across this YouTube series by an absolute legend called Lively Geek, merely a month or so of trying to figure everything out myself has passed. This guy really explained everything I needed to properly get started though. From creating and using my first scripts to modifying the source code and building the engine from that modified source code. Okay, once again, here we are for, what is it, the fourth time? Anyways, for the voxel structure in the background I already had some ideas. In the old project I simply stored one object for every single voxel, which was the main reason for why the memory usage was so incredibly bad. To tackle this from the get-go, I decided to work with IDs. There is still an object for every voxel type, storing the corresponding properties, but when the terrain manager loads in, those get mapped so that each one has its own ID. This way, a chunk only has to store an array of single byte IDs that can be mapped back to the corresponding terrain types whenever needed. That wasn't quite enough for me though. I decided to go one step further by compressing those IDs. You see, usually in a chunk you have mostly the same IDs. You very often have only air, occasionally only rock, and when the two meet, you usually end up with one material on top of the other, separated by a mostly horizontal border. For that use case I had two algorithms in mind, but decided to go for the one that's easier to iterate through, since I'll need that for the mesh generation. I don't actually know if it has a specific name, but basically I take all the terrain types from a chunk, put them in a single array in order, and then count how often in a row a type occurs. I then write those occurrence counts into a separate array and can throw all the repeating types from the first array. This technically can end up with more data than pre-compression if the types are changing every single voxel, but usually these two arrays end up being much smaller than the original array. If a chunk is completely filled with a single type, like air, we even only end up with a single entry for each array, where the occurrence count array is technically not needed at all, since we know that every single voxel is that one type anyway. So that's the material types for the terrain sorted out. We are missing something though. Every single terrain voxel should be able to have a different weight, which is what allows for the smooth gradients and shapes, as opposed to just cubes. Of course I could just have the terrain be smoothed out by an algorithm, but that wouldn't allow for detailed features or intuitive modification by the player. So instead I decided to reuse the terrain type ID system for those weights. Rather than mapping the single byte numbers to the terrain type objects, I just convert them to a float number from 0 to 1, which represents the weight for a single terrain voxel. Also, most voxels will have the same weight, since only the voxels bordering other terrain types need different weights to indicate where between the voxels the mesh should be. But I'll get to that when we talk about the mesh generation algorithm. These relatively rare deviations from the default weight allow me to use the same compression algorithm I use on the terrain types with pretty good efficiency. So far for debugging this, I basically spawned a bunch of cubes, but I think now it's finally time to dip my toes in the water that is Unreal Engine Mesh APIs. First of all, this is much more complicated than in Unity, because of course it is. There are different mesh components which each have their own mesh objects. There is the uStaticMesh component that can render uStatic meshes, which internally contain fmesh descriptions. This is the most common and most supported mesh type, but when you generate it at runtime, it is significantly slower to push to the GPU the first time, since it does a lot of aggressive caching and uses the static draw render path. Then there is the uProceduralMesh component that represents a bunch of fProceduralMesh sections, which can all be updated individually with minimal overhead, since it uses the dynamic draw render path. But because that's not enough, there is also a uDynamicMesh component that renders a fDynamicMesh 3, which is also really fast to push and update, but all these have the problem that they get really slow if you have lots of them, since they have to be pushed to the GPU every single frame, since they don't do any caching. I hope you got all that. Unfortunately, this happened to me multiple times with Unreal Engine. Seemingly simple topics that turn into multiple day or even week-long rabbit holes where you end up picking the static mesh, because it seems to make the most sense, since every mesh you generated stays there for at least a few seconds, but then you implement it and have to completely redo it, because it is even slower to build those static meshes for every chunk than you could have imagined, so you have to re-implement the entire thing to use the dynamic mesh anyways. Okay, enough mental breakdowns for now. As I had now figured out how to render the meshes for each chunk, it was time to figure out how to create those meshes in the first place. There definitely is no shortage of algorithms on the internet to choose from. For the Unity project we ended up using marching cubes. This algorithm iterates through all the voxels in groups of 8 and uses one giant table to decide what triangles to place between those voxels. It worked great at the time and was pretty easy to implement, but there were two things about it that annoyed me. The way it triangulated the terrain, especially on slopes, didn't look very good. It also was impossible to assign materials in an intuitive way, since every triangle is the result of up to 7 different terrain types. In the old project, our solution was to mix the colors of all the terrain types involved, but I was never really satisfied with that. So after diving into that rabbit hole once again, I ended up going for a modified version of the dual contouring algorithm. Just like with marching cubes, I first iterate over the voxels in groups of 8. But in that first iteration, I merely determined the position of a single vertex of the mesh using the weights of the voxels. In the second iteration over all those generated vertices, again in groups of 8, I connect those with outwards facing quads, and by looking at the voxel in the center, I know what material these quads should have. And just like that, we got smooth terrain that I can look at and individually break and place parts of. This highlighting effect I made by running the meshing algorithm separately on a 3x3 of voxels around the closest non-air voxel I'm looking at. So I shoot a raycast, or a line trace as it's called in Unreal Engine, from the camera straight forward, and then I pick the closest non-air voxel to the impact. I'll get to the UI and inventory stuff you can see here in the next video, where I will also get started on the blocks for building, since building a house with terrain is not ideal, and I also want to make a universal functionality system for the blocks and terrain. For this one though, I want to thank you a lot for watching, and hopefully I'll see you again in the next one.